Okay, we're continuing with section 12.6, other coordinate systems practice problems, and this one is problem number 14. It asks us to convert the spherical equation rho equals sine phi, sine theta, into rectangular coordinates, and then describe what this guy actually is. Okay, the tricky part is that we've got a equation that says that rho sine phi sine theta is equal to the y coordinate. That's a rectangular to spherical conversion. And this one's almost there. All we need to do is multiply both sides by rho. So what this will be equal to is rho squared. So if I multiply both sides, then I get rho squared is equal to y. So that's almost in rectangular coordinates, but of course rho squared, that comes from the Pythagorean theorem. So this then is equal to x squared plus y squared plus z squared. That's what rho squared is. So that means a replacement for this guy is that y equals x squared plus y squared plus z squared. Now, that's it. That's the complete formula in rectangular coordinates. And I know it has something to do with a sphere because of the x squared plus y squared plus z squared, but this extra y is tricky. It means I don't really know what the radius of the sphere is. So instead, let's write it this way. This is going to be x squared plus, and then I'm going to leave some space, y squared minus y, and then I'll leave a little space, plus z squared equals 0. So that's the same formula rewritten. And of course, what I want to do now is complete the square in y. Half the linear term is negative 1/2. Squared is positive 1/4. So I'm going to add that to each side, plus 1/4. Now this center part factors, and it's going to factor into y minus 1/2 quantity squared. So it's x squared plus y minus 1/2 quantity squared plus z squared equals 1/4. And now we can see what it is. This is a sphere that's centered at 0, 1/2, 0, and it has a radius of 1/2. So it'll be a sphere sitting on the y-axis, actually at 1/2 on the y-axis, this being 1, and the sphere will occupy that position. It's a radius of 1/2 sitting at 1/2, so it just touches the origin and 1 on the y-axis, and that's what this guy turned out to be the formula of. So we convert it. It was hard to recognize, and keep in mind that in order to describe a sphere, you will have to put it into standard form.